Hello students, welcome to AriserTalent. I am your math teacher Arpita Sharma. Okay, so in last session we discussed some questions regarding HCF and LCM. Okay, and we were discussing a question. You did that? This question? There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of field and Ravi takes 12 minutes. Okay, both start the same point and at the same time and go in the same direction. They started at the same point, same time and went to the same direction. After how many minutes will they meet again at the starting point? First is, this is your question 7 of exercise 1.2. Okay students, and moving forward we will understand what the question is trying to say. It's saying here are two persons, Sonia, okay, and here's a ground, circular ground or field. Now here's Sonia and here's Ravi. They started their vehicle at the same time. Now Sonia will reach on this position. They are moving in same direction. So Sonia will reach at this starting point again. In what time? 18 minutes. And Ravi is doing the same. In what time? 12 minutes. Now, according to question, they are continue revolving around this particular field. Now, what will be the time when they will meet each other at this starting point again? Okay. So, how will we solve it? It's nothing but we have to take the LCM of what and what? The time taken by Ravi and the time taken by Sonia. Okay. So, that LCM will be the time, that particular time at which Sonia and Ravi will coincide again, will meet again at that starting point. Okay, let us solve this question now. So, solution. Time taken, this is given, okay. Time taken by Sonia to drive one field round equals to what? Nothing but 18 minutes. Okay. Second, this is time taken. Correct it. Again, time taken. Do it with me. Time taken by Ravi to drive one field round equals to what? 12 minutes. So, time taken to meet again at this starting point. At this starting point he is asking about. Okay. At the starting point, when both are moving in same direction, okay, that will be equals to LCM of what? 18 and 15. And for the LCM, for getting the LCM of 18 and 20, 18 and 15, 18 and so LCM of 18 and 12. Now, how will you find LCM of 18 and 12? We will do just the prime factorization of 18 and 12 and we will snatch the highest prime numbers. Okay. Now, factorization or say prime factorization. Prime factorization of 18 will be what? 2 into 2 into now prime factorization of 18 will be equals to 2 into 3 into 3. 3 is a 9 multiplied by 2, 18. So, these are the prime factorization of 18. Now, prime factorization of 12 will be 2 into 2 into 3. We can write it as 2 raised to power 1, 3 raised to power 2, here 2 raised to power 2 and 3 raised to power 1. Now, in LCM, we will snatch highest power. So, LCM of what? 18 and 12. So LCM of 18 and 12 will be 2 and 2 is power 2. So, the highest one will be 2 raised to power 2. 3 raised to power 2, 3 raised to power 1. Highest will be 3 raised to power 2. That will be 4 and 9. That will be 36. Okay. So, we will get 36 minutes as our answer. So, after 36 minutes, both Ravi and Sonia will re-meet or will meet again at the starting point. Okay. Now, first note this question. Okay. I am rubbing this one and the answer is there, 36 minutes. We will explain this answer theoretically to you. Okay. So, what happened actually? This was the circle. Total time is 36 minutes. Okay. So, Ravi started. He completed one round in 12 minutes. So, after 36 minutes, he completed 4 rounds. Okay. He completed 4 rounds. 1, 2, 3 and 4. He is again here after 36 minutes. Now, look at Sonia. Sonia was here and she started at the same time after 36 minutes. We have to see whether after 36 minutes Sonia is here or not at this particular point or not. Okay, so he used 18 minutes. Now exact at 36 minutes, exact after 36 minutes, Sonia will complete 2 rounds of this circle. So at this particular moment, Sonia is here, Ravi is here. So they will re-meet or they will meet again. Okay, sir. Answer is also justified here. If you look very carefully the language of question, you can easily predict whether this question is going to solve by HCF or LCM, right? Now we'll talk about our next topic, which is irrational numbers. We have talked earlier about these kind of numbers, but we will define it first, that we have done in earlier classes also, right? Okay, but what is the difference between studying irrational number before this and studying irrational number in 10th standard? Before 10th standard, you just know that these and these are irrational number. In this particular chapter, you will prove that this particular number is irrational. You will prove them, right? So what are basically irrational numbers? We have studied rational numbers are what? Any number that can be written in the form of P by Q, where Q is not equals to 0, is known as rational number. And any number, remember that S is what? Any number that cannot be written in the form of P by Q, and it is an irrational number. So first, going with the definition part of it, when P and Q okay, any number that cannot be written in the form of P by Q, where Q is not equals to 0, is termed as what? Irrational number, right? And we discussed some examples also, like this pi, that root 3, that root 5, 7, and so on. So in this particular chapter, we will talk only about the square roots of prime numbers. We will prove them that they are actually irrational. We will prove them. Okay. Note it. Okay, moving forwards. Let P be a prime number if P divides if P divides A square, then P divides A, where A is a positive integer. This is a theorem we need to prove. Okay, this is a theorem we need to prove, because on the basis of this proven theorem, we will then prove then root 3 or root 2 are prime numbers. That root 2 and root 3 are irrational numbers. Okay. So let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. What do you want to say? If you are having any prime number P, okay, and A is an what? Always positive integer. If P divides A square, then P should also divide, A should also divide, A will also be divisible by P. Okay, we have to prove this. Now, we'll start with a proof. So, let the prime factorization, let the prime factorization of what? A. A is what? Our positive integer, any positive integer will be P1, P2, P3, P4 up to Pn. Okay. Now, if this is so, then what will be the square of A? What will be the square of A? A square will be P1, P2, P3, P4 up to Pn, multiply by again P1, P2, P3 up to Pn. Okay. Now, we have given that P divides A, P divides A square. If P divides A square, that means there is in this set, in this particular set, there is a term P that can be P1, P2, P3, P4. Okay. So, in this particular term, there is a particular term P. Now, because this set is this set are all same, here we also have a number P. So, P, so here A square is divisible by P. Okay. This proves that this set A also contained any of these prime factorization as P. So, this A is also divisible by P. So, P is also a factor of A. So, this proves that P is also a prime factor of A, and exactly this is what we have to prove. If P divides A square, then P divides A. Okay, note this. Okay, this theorem is important because we are using this particular theorem to prove another statements I have told you, like this, root 2 is irrational. Now, what we are going to do, if we'll use a simple technique here. What we'll do? We have given this statement that root 2 is irrational. We have to prove this. Now, on the contrary, we will assume that root 2 is rational. Now, if we proved that root 2 is rational, what we assume is not correct, then what will it become? Then obviously, if root 2 is rational is wrong, then root 2 is rational. Okay. So, proof. On the contrary, let us assume that root 2 is rational. Now, any rational number can be written in the form of P by Q. Okay. So, root 2 is equals to P by Q, where Q is not equals to 0. Now, P and Q are some positive integers. Now, let us assume that there is some common factor in P and Q. So, we will divide this by this common factor and we will remove this common factor. So, assuming that there may be is a common factor in P and Q, we eliminate it. So, it will cancel out obviously. So, now root 2 will become A by B. Mark this, where A and B are co-prime. You have read this word co-prime in your previous classes, but if you are not able to recall it, let me explain it to you. What does that term mean, co-prime? Two numbers are co-prime if there is no any common factors between them. So, these terms are now co-prime because we have removed the common term here, right? Now, we will square both the terms. Squaring equation one. So, what will it become? 2 equals to A by B. Okay. So, this implies that A equals to 2B. Equation second. So, A is a multiple of 2. A is having factor as 2. So, now squaring equation 1, 2 will be equals to A square upon B square, and that implies that A square equals to 2B square. This is equation 2, right? Now, in the previous theorem, what we have proven that if A square is having any factor, then A will also have the same factor. So, if A square will be having 2 as its multiple, so A will also be having 2 as its multiple. So, by previous proven theorem, we can write what? A equals to, let's assume C as any positive integer. So, 2 multiplied by C. Okay. Now, substituting the value of A in equation 2, what will get? 2C square equals to 2B square. 2c whole square equals to 2b square. What will it become? 4c square is equals to 2b square. Now, by this, we'll get b square equals to c square. 2b square equals to c square. This means what? That b square is having a factorization of 2. Now, again by the previously proven theorem, if b square is multiple of 2, so b is also multiple of 2, right? Note it. Note this part. Okay, I'll rub this section only. Now, we are having 2 in multiple of b. We are having 2 in multiple of a. Okay. So, a by b is not co-prime because a is also having a multiple as 2 and b is also having a multiple of 2. So, this is not co-prime. They are having some common multiples. They are having some common factors. Okay. So, this is not true. And why it's not true? Because the assumption we made the assumptions we made A by B is co-prime. So, the assumption we made that root 2 is irrational is what? Not true. Hence, the opposite is true. The opposite is what? Root 2 is irrational. Hence proved. Okay. Note it. Now, the next question is same. The way we illustrated that root 2 is irrational, you have to illustrate that root 3 is irrational. Now, the procedure will be same. Okay. So, you have to do it on your own. Okay, next lecture I will see if you did this or not. Our next question is, let us assume that we have proved root 3 is irrational. Now, our next theorem is 5 minus root 3 is irrational. We have to prove the statement 5 minus root 3 is irrational. Now, what we do in each and every case, in this scenario, we will assume in contrary that 5 minus root 3 is actually a rational number. So, in proof, the very first thing we will write is, let us assume in contrary that the given value 5 minus root 3 is what? Irrational. Sorry, rational. it's rational, right? So if 5 minus root 3 is rational, so that can be written in the form of P by Q or A by B. Okay. So 5 minus root 3 equals to A by B, and A and B are here positive integers and B is not equals to 0. Okay. Now what will it become? A minus B minus 5 will be equals to minus root 3, or minus root 3 will be equals to, or root 3 will be equals to 5 minus A by B, that can be written as B 5B minus A. From this equation, root 3 equals to 5B minus A by B. What do you conclude? That this equation shows that root 3 is rational. Now, as root 3 is irrational, root 3 is irrational, so we can say that this is due to our contrary statement, wrong assumption, that 5 root 3 is rational. Hence what? Speak. 5 minus, hence 5 minus root 3 is irrational. Hence proved. Note it. Okay. So we have done the theory part. Here we will discuss some questions on it in next session. Thank you.